you would not. Person equal person. Student object from day38 left name. Yes. Now in the same way you have all the stuff named SQL queries. So SQL query need to be supplied with the entity that represents the table. Select star from address. You can specify session dot create SQL query of SQL and specify the class that it represents. So now actually in the system I think we have this as like person 5. April. And then this one named SQL queries. If in case if you're selecting this, SQL can be used to return the non-managed entities, and the entity instances written may not reflect the latest value. That is, it is not associated with the persistence context. That is, you did not register the bean in what you say in Hibernate configuration file. Then that will come under non-managed. So select lane capacity from address velocity like something. Create SQL cell. What happened to this? So select start from person 5, John and John 5. So over here if you see again, now you are select start from person, you're not doing, you're doing select start from person 5, because in the database it represents this table, person 5, whereas your entity name is person. So far we have been doing select start from person, we have been doing select star from person we are doing. That is, you were querying the entity over here. Now you're not querying the entity, now you're querying the uh, SQL, right? How you write on the MySQL, the same way you're writing over here, native SQL queries. So for that purpose, you have to specify this person phi, it represents what's person.class. Now returning non-managed entities means over here in the Hibernate configuration file, where is that Hibernate config file? In the Hibernate configuration file, whatever queries you have registered, the files would have been registered over here will come under managed entities. Rest will come under non-managed entities. So over here, person address, item and build will come under managed. And if you're querying anything other than that, okay, that will come under non-managed. So whichever classes you are registering over here, that will be managed by the Hibernate. The rest you can say it is not managed by the Hibernate. So select lane capacity from address 5 is city like something, and then session dot create SQL query, set result transformer, you're saying transformer dot alias to bean, transfer this to this address dot class, and specifying set string and all. Non-managed. So what do we have over here? City, state. So city, city, right. mattress. And in the same way, new query, you can do it. SQL query, you have to write it in the class file, and then okay, you can get the data from here. And then you have got the, from version 3, it has introduced the support for the queries where stored procedures in function. And the condition that we have is it must return a result set as the first out parameter to be able to work with the Hibernate. Reference cursor. So it is returning this value A. And then in the custom SQL, we have got like SQL insert, callable is equal to true. This is how you're calling the procedure. Call create user, and then you're passing the two parameters. Delete user, passing the username, and then again returning the value. This you do it. Next, let us start with the Hibernate transactions. Transactions we have already done. Like most enterprise applications working with the database system need to make use of the data integrity. You have to specify where the transaction will start and where the transaction will stop. So session.get transaction.begin and session.get transaction.commit. So we are specifying where the transaction starts and where the transaction ends. And the Hibernate, it makes use of the underlying JDBC and J2EE technologies in order to support the transaction. So over here, if you observe this diagram, now over here if you see, for managing the transactions, again internally it makes use of the JDBC and the JTA, Java Transaction API, in order to support the transaction. So it will abstract the application away from the underlying JDBC and JTA API. The transaction API is built on top of that. So Hibernate acts as a client to JDBC and JTA transaction, allowing the application to make use of the features while not worrying about the technical complexity. So it is just abstracting it. And then you can start the transaction by calling session done begin transaction. And when you're done, okay, you can call the commit and then the rollback. Now the advantage what you get over here when you're using this Hibernate transaction is, let's say your application is you've got many entities over here. Entity 1, entity 2, and then okay, you're having entity 3. So all these entities, let's say okay, this belongs to one database and then okay, you're having one more database, and then okay, you're having one entity, 2 to 3 entities over here. 1 minute. So let's say this is one database, and let's say this is the another database. So we are having entity over here, 1, 2, and then 3. And you have your application over here. This is your application logic. Your application is interacting with this database, as well as in order to query, it is interacting with this database also. And let's say for a particular transaction, it has modified this. Okay, this entity has been modified. So this entity is modified, as well as let's assume this entity is also modified. And these both are connected. This is also modified. Now when you say rollback, let's say okay, when you say rollback, it will roll back this also, and it will roll back this, as well as it will roll back this also. So you don't have to go to that specific database and then again invoke the rollback command. Internally, okay, whichever entities has been modified, it will roll back those. If you have to, let's say if you have to save this entity, if you have to save this entity, save as, it will save this, it will save this, as well as it will save this. So this is the advantage you get. So you will just give the command rollback, and like internally it has to update, rollback, or commit all the related entities. You don't have to go to a specific entity and then say rollback, or then say or invoke commit or update. The moment you say on one entity, it will perform the commit or update or roll operation on all the associated entities. That is the advantage you get. So that is what it says. Hibernate act as a client to the JDBC and JTA. Align the applications to make use of the features and not worry about the technical complexities. And flushing Hibernate session. Now what do we mean by flushing? Now if you see this diagram, over here you have got your session object. Over here you have got the session object. So whenever you're creating a session, some memory is allocated to that. This one session, it is taking care of your persistent object. So whenever you create session, some amount of memory is allocated. So some amount of memory is allocated for your session. Now, when you are saying session dot save of person P, or session dot save dot address of A, and this session object is in turn now again associated with this database. Where is the database file? So this session object is associated with this database. Now when you're calling save, we are thinking that this is going to go and update the row in the table. Now, let's assume this is the row in the table. One for the person object, another for the your Now when you say session.save of P, what happens over here is it is going to save this object in the database. Sorry, it is going to store this object in the session scope. It is not going to save this object in the database. And let's say okay, you're having some XYZ fields. Field 1. So this person object actually did not move this to the database. It has rather kept it in the session scope only. Now let's say after you have saved this session object, after you have called this session.save, now then next again you're doing session.update of P. Now let's assume initially this one was 100 and then John, and next okay you're trying to modify this John to Tom. If you're trying to modify, it is not going to make changes to the database. We're trying to modify this. It is when you're trying to do this, it is not modifying or it is not making any changes to the database. It is not making any changes to the rows in the database. It is making changes to the objects that are stored in the session. It is making changes to the objects that are stored in the session. Now when you say John to Tom, over here it is going to make John to Tom. Let's say originally this row was 100 and then John. So now when you have pulled the object, it had retrieved this object. So let's say when you first step is, let's say okay, you told session dot get of person dot class dot 100. First step is like it will get this object, it will get this object from here and it will store it over here. In the session it will keep it 100 and then okay, it was originally it was John. Now next okay, you are making changes John to Tom. It is not directly going and updating the row in the table, rather it is performing changes over here. It is making changes over here. So all the changes whatever you're making will not be persisted into the database. It will not be applied to the database, rather it is applying the changes to the objects that are stored in the session. So that is what it says. Changes are made to the persistent objects in a session are stored in memory. Session implements transaction right behind whereby the changes are written to the database in a transparent manner and to the So flushing of the state occurs when transaction is committed before a query is executed when an application calls flush. So unless and until you call commit session.commit, when you say session.commit, then only it is going to update these changes over here. If you don't call commit, the changes will be over here only. It is not going to update. The changes will be made to the persistent object that is stored in the session. When you call session.commit, then at this point, this is going to get updated 100 to Tom. And until then, it will be stored in the session only. So session implements the transaction right behind mechanism. So when a transaction is committed before a query, or if you're calling session.flush, then the changes will be made permanent. When you call commit or flush, then only it will update the database. Otherwise, it will not update the database. So transaction isolation levels. So transaction isolation level will attempt to segregate the concurrent transaction in the view. So you have got the multi-locking version mechanism using the version number or the timestamp. So over here, version name, version, and the column by name is like version. That is, whenever the row is being updated, it will get the version number 1, 2, 3, 4. Let's say column 1. So from Tom you have modified it to John. So you are getting one version. So internally again it will keep the version number as 1, 2. If in case if the column is again modified, it is like 3. Column is modified, you will get the number as 4. So internally it will create a column by name version where and it will track the number of times the column has been updated by specifying the version number. So you should always get the latest version number. So as you see, whenever an object is changed, Hibernate will automatically update the version number. So whenever you are fetching an object, its version number is also fetched. When the object is in the detached state, the corresponding record is updated within, so then the version number in the detached object will be older. And any update issue for this detached object will result in a failure since the update query will check for the current version and which will fail with the stale object state exception. Now over here, it will give a version number to each query. Let's say its version number is 4. Here also it records that. Version number 4. Now after you have updated this, and okay, after you have given the commit statement, the session is closed and this object is detached object. That is, this object will move out of the context, out of persistence context. In the meanwhile, some other session or some other user has updated this. Let's say it has updated this 5, John, Johnny, and let's say this has been updated and its version number has been again updated. After this version number has been updated, if any session, like if you're trying to make update to this object, again if you're trying to update this object, this query will fail. This query will fail because now when you're trying to update, again you can update the detached object also. So when you're trying to update the detached object, Hibernate will cross-check this version number with this version number. So this version number and this version number does not matches. So in that state, okay, you will receive an exception called object is stale. Object stale exception you will receive. State of stale object state exception. Since the update query will check for the current version in the table to be the same as the version number in the detached. So if it is not same, it is going to fail. This should be enabled. You have to like enable all these properties. And then when you are done, you can disconnect as well as you can reconnect the session. To disconnect from the database server, you can give the code session.disconnect. At this point, session object is still valid and will be tracking any changes to the object previously loaded to the application through the session. And when the application gets the control back, it will be connected to the database using session.reconnect. Hibernate extension is not required. Just wait for 2 minutes. Now, next what we have is Hibernate cache. Now, in the Hibernate cache, one of the benefits of using Hibernate is the ability to cache the instances. Caching of the data in the entity instance can provide great performance benefits, and it provides configurable caching where each cache class can be separately enabled or disabled depending on its usage, and it provides multiple levels. So first let us understand what you mean by cache. So Hibernate, it provides you with the two level of cache. One is first level cache, the second one is second level cache. So first level cache is enabled by default, and in the second level cache you have the option whether you want to enable or disable it. So all the objects, as we have seen over here, we have like kept session over here, and all the objects like are stored in the first level cache by default. Whenever you say get, update, delete, anything, all the objects will be stored in the cache memory itself. This cache memory is associated with the session object, and it is enabled by default. You cannot disable it. So all the objects on which we are trying to perform any operation will be stored in the first level cache. And first level cache is associated with the session object, and you cannot disable it. Second level cache is associated with the session factory object, and there you have got the options to enable as well as to disable it, but first level cache is enabled by default. So two levels, one is like session cache, and which is enabled by default, you cannot, and the second level cache is associated with the session factory. You have got process cache, you have got clustered cache, you have like queries cache. Process cache is shared between many units of the whole transaction. It is shared between the processes. Clustered cache is shared as the name itself indicates. It is shared if in case if your application is interacting with more than one system, then you can go with the clustered cache. And then you have got query level cache. If in case if you want to store the queries, rather select star from employees, if you want to store that, then you can go with the query cache. Now, all the persistence instances that are in the persistent state, as we discussed, they will be in the first level cache, and changes are made and a unit of work are done in the first level. So if you are making any changes, it will be done in the first level cache, which we have already discussed. And then changes are made and written to the database only on flush or when you're calling the commit. You can opt not to keep the data in the first level cache by using the edit method. So once you are done with the commit, then if you don't want this data to be stored on the first level cache, then you can call session.evict method. So when you're calling the session.evict method, all the objects that are stored in the first level cache will be removed. It will clear this. You will not have any data. Let's say over here you were having two objects. Two objects were stored in the first level cache, and when you call session.evict, it will remove this data from the cache. It will remove all the objects that are stored in the cache by calling session.evict. And not useful for Hibernate that deals with the bulk or large quantity of data. In such a way, we better off using the plain SQL or the stored procedures. So when to go with the SQL and when to go with the procedure is because the amount of storage what you have in the cache is very limited. If in case if you're writing a query wherein it is going to fetch huge amount of data, so if you're writing a query when it is going to fetch a huge amount of data, so this memory, this cache memory may not be sufficient. The cache memory may not be sufficient to store these many objects because like this memory will not be sufficient. In that case, you can go ahead with the native SQL queries or the stored procedures. If the amount of memory is not sufficient, if your SQL queries are retrieving the bulk amount of data, when it comes to processing, then the amount of memory may not be sufficient to store that much amount of data, as we can see over here. In that case, you can switch back to the native SQL queries. So now over here, second level cache means um, let me take some other one. So you have got this. Okay, let us assume this is second level cache and this is your first level cache. Now, if in case if you have created two sessions, if you have created two sessions, then each session object will get its own separate. Let's say you have created some two session objects. This is session object 1 and this is session object 2. You have created two session objects, S1 and this is S2. If you have created two session objects, then each session object will get its own first level cache. So first level cache for this session object, and this is the first level cache for the other session. So this first level cache is associated with this and this one is this. Now any operation you are performing on this object will be stored over here. By default first level cache. Let's say okay, you're making any operations, it will be stored over here for the first level, and for the second level each one is associated. It is like 1:1 mapping, you can say. First level cache is 1:1 mapping. Now, whereas when it comes to second level cache, if you prefer to store the objects in the second level cache, what happens over here is all the processes or all the sessions will have access to the second level cache. So if in case if your application is using second level cache, then this is what happens. It will store the object in the second level cache, and this second level cache is accessible to all the session objects. So this object can also access this data, and as well as this session object can also access. Let's say you are having one more session object created, S2. So this one will also have access to this. So everyone will have the access to it. Clear with this? So now, in the second level cache is enabled. So what it does is, first, let's say okay, now the second level cache is enabled. Now when the second level cache is enabled, it will store the data first in this first level cache, and then as well as again it will store the same data in the second level cache also. This is what happens if you have enabled the first level cache, and if the transaction, if it is storing the data in the first level cache, then it stores the data in the second level cache. Now after you have closed this session, after you have closed the session, okay, after you have closed the session, so this session object will be discarded by the Hibernate application, and then again you will lose this session object as well. You lose the second object. Let's say this is your employee object, and now if you are giving the query select star from EMP, so the process is, first it will check whether the data is available in first level cache. If it is available in the first level cache, it will return the data from the first level cache, and if the second level cache is enabled, if it does not get the data in the first level cache, then it will check whether the data is available in second level cache. Now let's say okay, now this session is giving the statement. Now let's say okay, sorry, this one, let's say this session, it is giving the statement. Now this session is having the first level cache for it, so this session is giving the statement select star from EMP. Now first Hibernate will check whether the data is available over here. Hibernate will check whether the employee object is available in the first level cache. It is not checking in the database. So first it is checking in the cache whether the data is available. Because it is not available over here, then it will go to the second level cache and then check it. If the data is available in the second level cache, it will get the data from the second level cache and then return it. Now let's say you are connected to the, now next okay, let me draw a database. Now let's say okay, this is your database object. Now this is what it happens. Now let's say rather than employee, now next query what you're giving is select star from department. Now when you're giving this query select star from department, the same process happens. So first it will go and try to check whether the department is available in the first level cache. The department is not available in the first level cache. If it is not available in the first level cache, then it will go and check whether the department object is available in the second level cache. Because the department object is again not available in the second level cache, then finally it will go to the database and then get the department table. So this is how it works. Now by default your first level cache is enabled. Now if you just see this, now like you can easily Now over here, if you see fetch person address, you are fetching the data for the first time. Query is equal to something. We will repeat this. Okay, I'm repeating the same stuff. System.out.println. This you are repeating it for the second time. Fetch person address, run as Java application. 1 second. A.set. Okay. Now if you observe over here, it has executed the select statement only once. Did it execute it 2 times or like only 1 time select statement? You're not getting select statement twice. It has executed the select statement only once, and once you have executed the statement, now this object is available in the cache. It has executed the session employee object, whatever you have created, it is available in the cache, and the second time it is not executing the execute statement again, it is getting the object from the cache. Now if you observe this, object is persisted. After that, okay, you're calling this from where to 2 times it is calling. after you have created this person, and then okay, fetch person address when it is calling. From here, where is that fetch person address? Oh yeah. Now, two times you are executing this stuff. Select statement, you're executing it two times. So when you're executing it two times, okay, it is not issuing the query twice. It is not giving the select query twice. So if you observe this on this on the console, it has printed the output twice, but it has executed the select query only once. It it is not executing for the second select query. It has printed only once. So that is okay. It is fetching the data from the session. This is for one. This is first time. So if you observe, okay, select staff from person 5. So total, okay, how many rows you have? 2 rows. So 2 rows means it should execute that select statement twice. Now, 1, so if you want to use the second level cache, by default hibernate.cache does use second level cache. It is set to false, we need to set it to. If you want to disable it, then you need to go to the Hibernate configuration file, and you need to, sorry, this is this. So under properties section, true is you have enabled and false is you have disabled. So after you have enabled this, then there are various cache providers. So you need to specify which cache provider you are using it. So EH cache provider is one of the organization that provide caching mechanism. So you need to specify like which provider class you're using. So if in case if you're using this EH cache provider, then you have to mention that also in the Hibernate configuration file. And then again you have to specify it. Default cache is 1000 memory, true or false. Total idle second is 120. Total time overflow is true. You can specify the cache name and all. Okay, this we will be doing it tomorrow. And then again, you have to specify for which class you have to enable the cache. Read only, all these things again we will do tomorrow for caching. It's not possible to complete today. Query cache. Okay, tomorrow we'll complete this caching. Not possible to complete today. Tomorrow we'll do. If we complete caching tomorrow, then we will start with the web services.